All right, so we're going to start with the introductions now. The way that this is going to work is I'm going to page through the slides up here, and you're going to turn on your seat mic. When you see your name, you're going to turn on your seat mic, and you're going to talk into it. And if you go over 1 minute, I will start. I'm looking at the clock up here, and I'll start making horrible sounds. Oh yeah, that's a great idea. So also please raise your hand so that people can connect the face to the name and that kind of stuff. That's a great suggestion. All right. Any questions before we start? All right, Rodrigo.
Okay. Before I start, 10 seconds to just mention that I've gone through and everyone who gave me their GitHub username, I've added you to the mailing list. And if you're in that camp, your logo up there is green. So that up there, top right, is my GitHub username, and it's green. It means you've already been put onto the mailing list. So if you haven't done it yet, please add your GitHub username there, and I will incorporate you into the discussions page. Okay. I'm Rodrigo Luger. I'm a postdoc here at the CCA. I work mostly with characterizing transiting planets and thinking about exoplanet mapping. But here, my goal is to learn more about microlensing. I have very little experience in the field. I'm interested in the things Dan talked about concerning derivatives and machine learning and applying that to microlensing. And in terms of things I can contribute, in addition to moral support, all sorts of coding stuff, Python, C++, TensorFlow, and some machine learning stuff.
Hello, I'm Rachel Street, for those of you who don't know me, staff scientist at Las Cumbres Observatory. I've been studying microlensing primarily from an observer's point of view for about 10 years. I also work on a range of other stuff, and I'm moving more into modeling and machine learning these days. So I'd like to work more on the actual modeling and also the event characterization using machine learning techniques. But I have experience with Pylema and software development in general, and also photometry data assessment. Happy to help with anybody if they have any queries.
Okay, I'm Samek Murs, still a graduate student at Warsaw University Observatory. I'm working in the Ogle team. I was working on many aspects of microlensing, like modeling of binary events, some extremely difficult events like Gray event. I was also doing some work on searching for microlensing events, distinguishing microlensing events from other sources, so I can help with that also. Okay, thanks.
So I'm postdoc at Ohio State University. I'm working on K2 campaign 9, so if you want to work on that, we can do it during this meeting. I'm also involved in W1st preparations, and I'm member of the Ogle team. I have some experience with different routines for fitting microlensing events. So and different codes, different languages like Python, C, or Fortran. But what I would like to know more is vetting of the data, Bayesian model selections, things like that, and more MC samplers. And if you want to know more about Newland's model, just ask me.
David Bennett. I'm an old man of microlensing. I've been working on microlensing for about 30 years and working on space-based microlensing for almost 20 years. I've done a lot of work with microlens modeling, particularly triple lens events. I'm interested in statistical analysis, extracting planetary parameters from microlensing events, proper weighting of Bayesian models. I told you sort of the stuff I was hoping to work on in my talk. And I can also entertain the young ones with stories of old days of microlensing.
Stella. I'm a PhD student in Catholic University in DC. So I'm very new in the field. The first time I worked was during the data challenge. I work in the Mulan team. And I would like to learn, well, I'm open to learn everything since I'm new. and I can help with Mulan if you need.
I'm Bartolich. I'm a second year PhD student at St Andrews in Scotland. I'm interested in Bayesian modeling of microlensing events, and for this hack session, I'd like to work on hierarchical models in particular. I have some code which is like close to being functional in that sense. And I can help out with PyMC3, so Hamiltonian Monte Carlo, if anyone's interested, some GPs, and model comparison.
Hi, I'm Matthew Penny. I'm a postdoc at Ohio State. I've got extensive experience simulating microlensing. In my early career, I did some automated fitting of binary microlensing event with various levels of success. I think about survey design a lot and pipeline development as well. I'm interested in helping others mostly while I'm here, but if that doesn't occupy all of my time, I'm thinking of working on some K2 stuff. Yeah, and I can probably help with anything.
Okay.
Hi, I'm Isser, and I'm a graduate student in physics at the University of Heidelberg in Germany. And yeah, I'm very new to the field, so I don't have a lot of experience, but I participated in the data challenge with the team Mulan. And if you have questions about how to use Mulan, I'd be glad to help you. And I'm basically interested in learning everything there is to know about microlensing, especially in data modeling.
Waiting the green light. Okay. So I'm Etienne Bachelet. I'm postdoc at Las Cumbres Observatory. I mainly work on microlensing since 8 years now. I'm interested to work on bizarre microlensing events and data statistics and all of that things. Here I would like to work on, to learn about how to properly rate the degenerate solution, also improve on microlensing tools and machine learning exploration. And I can help with SpyDema and some alternative approach for modeling.
Hi, Kaylin Henderson. Good to finally join everybody today. I'm a research scientist at Caltech at IPAC, and I've been involved in a variety of space and ground-based campaigns in a number of ways. I don't know who wrote. Yeah, I'm not sick anymore. It's fine. I'm not contagious. Probably Yossi. Thank you. Like to work on a couple of things. I'm really excited about derivatives now. I didn't know about them. Now I'm super excited. That sounds great. And I can help others with thinking about public data, using any of the holdings at the Exoplanet Archive, general microlensing questions. I didn't write it, but moral support as well. Thanks.
Can you use your seat mic, please?
And I'm interested in statistical studies using microlensing planet samples, and I'd like to learn triple lens modeling and Bayesian analysis. And yeah, I can help the modeling and general questions on microlensing. Thank you.
Hi, I'm here, Valerio Bozza from Salerno University. I've been working on microlensing since 2000, basically. I also done many other things in the middle, but mostly my main contributions have been the development of VB binary lensing and the RT model that I presented today in practice. And I would like to take the opportunity in this hack session to learn more about machine learning, which seems very promising for application to microlensing. And then I can help with VB binary lensing, of course, and I would like also to discuss methods for the automatic searches in a higher dimensional space, including higher orders and multiple lenses. So basically, that's all.
Hi, I'm Peter McGill. I'm a second year student at the University of Cambridge. So I've mainly worked on astrometric microlensing with Gaia, so predicting future events using Gaia's astrometric solution. So I'm interested in machine learning applied to microlensing and generally what Gaia can do. So the Gaia data is amazing, and I'm incredibly excited about it, and I think everybody else should be. So I can, if you have any questions about Gaia, specifically Gaia Data Release 2, I know a lot about the data and how it can help with microlensing. Generally, some things that I want to work on is early characterization of events and proper sampling with Hamiltonian Monte Carlo.
I'm Jan Skowron. I'm a postdoc at Warsaw University Observatory and a member of OGLE project. I'm in microlensing for a long time, so I can help with understanding data, surveys, systematic errors, parameterizations, interpretation of events, all this different stuff. And of course, I'm interested in unsolved problems, which are big, like triple lenses, different approaches to difficult optimizations, weighting of different models. So really would like to have discussions about this. Thanks.
Oh, that's me. I work here. I care about open source, and I don't think I've put it on here, but I'd be happy to help with sort of talking about packaging for open source codes and things like that. That's sort of one of my favorite things to talk about. You know, as I mentioned earlier today, derivatives. In particular, I'd love to talk to folks about how the exoplanet package that I just released might be useful with microlensing problems. It has all sorts of sweet derivatives and Gaussian processes and stuff like that.
Hi, I'm Katarzyna Kruszyńska. I'm a PhD student at Warsaw University Observatory. Mostly I'm working on microlensing in Gaia and how to look for it in order to find black holes, whatever. I have some experience in microlensing, but if someone wants to learn how to find Gaia data, how to use it, just ask me. I'll do my best to help you. But what I want to learn here is mostly modeling binary events because I have never done that. And I want to understand how to better model microlensing events, how to use my MCMC for that, if MCMC is fine for that or not, and also how to improve searching for microlensing events in large surveys. Yeah.
Hi, my name is Lisa. I'm a PhD student at McGill University. I mostly work on trying to study the atmosphere of transiting exoplanets. And so basically, I look at observation and try to infer something about their atmosphere or atmospheric dynamics. I'm interested in trying to see all the advances that the transiting exoplanet community have come in understanding red noise, systematics, and instrumental noise and applying it to microlensing. I'm also here to learn anything about machine learning, modeling of microlensing events. So I have a very shallow understanding, but I'd like to get a deeper understanding. I'm also a big fan of outreach, and so I saw that there was a project on citizen science, which I'm excited about. I can help with question about Spitzer, Iraq. I've used Pylema, Mulan just now, and I have some understanding of Bayesian statistics.
So actually, Geoffrey is has left, and now it's Clément Rank. The shutdown is finished. So I'm Clément Rank. I'm postdoc at NASA Goddard. I mostly work on microlensing modeling. and I'm very interested actually in like planet on wide orbits and brown dwarf orbiting stars, low mass stars especially. I really would like to learn more about and to test MCMC method to sample multimodal distributions in high dimension. I would like to learn a little bit about my machine learning and triple lens. So I think it's a program for several Hag Week. And I can help a lot with Mulan and any aspects related to microlensing and yeah, modeling.
Second year PhD student at Tsinghua University. I'm working on several microlensing groups. I would like to learn something about machine learning applied to microlensing modeling and event finder. I'm also interested in Bayesian analysis with blending constraint. I can help with CFT high resolution images and DIA pipeline using ISIS and search microlensing events using Andy's algorithm. Thank you.
Hi, I'm Maria Gabriela Navarro. I'm from Chile. I'm studying in Andrés Bello in Chile and Sapienza in Rome. I'm a member of the VVV team, and I have been searching for microlensing events with the VVV. So I would like to learn how to fit more complex models because I'm using PSPL, and how to deal with low cadence.
Hi, I'm Casey. I'm a second year grad student at UC Berkeley, working on simulating, modeling, microlensing from first principles, the popsicle stuff I talked about yesterday. I'm mostly interested in finding black holes, so I can talk a lot about that, or astrometric microlensing. Like to learn or work on, I guess, a lot of stuff, so I only know like baby statistics from high school, so anything with like Bayesian methods, or I also don't really work with data, so like dip my toes in reality once in a while, look at real data and how people model and fit light curves.
I'm Wei, currently a postdoc at CETA in Toronto. I worked on some microlensing modeling and understanding the data, for example, modeling the binary code and parallax with K2 spacer, together with ground and WFirst as well, theoretically. And I've also done some works on statistics, including microlensing, transit, radial velocity, and combinations of those. And I'm most interested in learning the triple lens modeling from various people and understanding how to get the microlensing multiplicity function and what can we do with that.
Hi, I'm Nathan Golovich. I'm a postdoc at Lawrence Livermore National Laboratory. I work on a few different things, but for microlensing, I'm focused on black hole microlensing, but I also work on self-interacting dark matter and merging galaxy clusters and surveying for near-Earth asteroids. So, but microlensing is kind of my main focus, so I'll talk about it here. Currently, I'm leading with Will a long timescale microlensing survey with DECCAM, and the data is all public, so if anyone's interested in that, it's out there. We're about 10 months into the survey, so there's not a lot of data, and it's long time scale, so it's kind of sparsely sampled, so not good for planets, but I just thought you guys should know that it's public and available. I'm interested in implementing the GP stuff that people have talked about here for correlated noise. It's a big background for parallax because the variable stars sometimes have similarly time-scaled noise. And I'm also interested in event detection, and then I can help others with various Bayesian analysis and other things like that. So thank you.
I'm Yossi. I'm a research staff at IPAC. I lead the Euclid and Spitzer microlensing surveys, and I'm also a member of KMTNet. I have some experience with microlensing both in observation, analyzing, and statistical conclusions. My main thing that I want to learn is new approaches of study, to have robust systematic exploration of binary lenses. I'm not a senior, and I'm not really young, And I must say that I was very disappointed by the approach of the seniors to Dan's talk of new ways to explore things. And I would be very happy if at the end of this hack session we can prove them wrong.
Sounds good.
Hello? Hi, I'm Yutong. I'm a PhD student at Harvard. I've worked on microlensing modeling with satellite parallax, Spitzer and K2 Campaign 9, and I've also some knowledge about stellar multiplicity statistics in general. I think I've had a good overview of the things that under the I would like to learn column, and I think you should see the rightmost column as part of that I would like to learn column. So I'm really interested in using satellite parallax to constrain models of the galaxy. I like to work a bit on K2 photometry with various people here, and also interested in how microlensing help us constrain stellar binarity statistics, be it binary lenses or binary sources.
Hi, my name is Samaya Khakpash, and I'm a PhD student at Lehigh University. I'm interested in microlensing, especially detection and light curve modeling. And I have experience working with simulated planetary microlensing light curves. I would love to learn more about modeling binary lens microlensing light curves, and also learn about machine learning and its uses in this field. And I also wanted to learn more about the existing microlensing survey data that I have already learned a lot. And I have worked with Pylema for modeling and simulating PSPL events. I can help with that, and also with simulated light curves if somebody needs help. I'm a PhD student from the University of Canterbury in New Zealand. I mostly have worked on modeling in the past, be it transiting exoplanets or binary lenses. I'm interested in more modeling stuff because there's always more to know when it comes to that. But I can probably help people out with a few things, I suppose.
Hi, everybody. My name's Savannah Jacqueline. I'm a PhD student at Vanderbilt University, and right now I'm primarily working on image level, point source, point lens, microlensing, event injection and recovery with UCURT, and basically trying to determine the near infrared detection efficiency and event rate. Basically, I want to learn all of the things and work on all the things, whether that be learning machine learning techniques, how to properly fit a light curve, statistics done right, basically everything that's listed up there. In particular, though, I'm interested in the UCURT Zooniverse project, and also the idea of creating new GIFs, or images from microlensing outreach in general. And what I can hopefully offer to you all is some help with Python, some really janky work with source extractor, and otherwise some outreach ideas to help expand the field of microlensing, particularly from the ground up.
Hi, I'm Josh. University of Tasmania in Australia. Work on adaptive optics follow-up of microlensing events, mainly planetary events, and I also do some modeling as well, which I've done with Pylema. I've modeled finite source binary lens events with Pylema, so I can probably help with that. And if you have any questions about Keck reduction and that kind of thing, probably other AO2, I can help with that. I'm mainly interested in figuring out contaminant analysis with Bayesian statistics for AO events, and also anything to do with photometry and PSF fitting. I would really like to know more about that. And in general, I'm always keen to get better at modeling, and specifically MCMC.
Hi, I'm Jennifer Yee. I'm from the Center for Astrophysics. I have a lot of expertise in microlensing. I'm the leader of the CAMTEEN-NET and Spitzer microlensing projects. And I helped Radek with the writing Milan's model. I'm interested in methods for modeling systematics and also dealing with outliers in time series photometry, so in microlensing data. And also in assessing the performance of different likelihood space searchers like MC or multinest for looking at like a degenerate parameter space and seeing how fast they are, how well they work. So I can help others with mu-lens model and just general knowledge of microlensing stuff.
Hello, I'm Łukasz Wyrzykowski. I'm a faculty at Warsaw University Astronomical Observatory. I work on microlensing since 2000, and since 2008 I'm involved in Gaia. This is primarily my main topic now, so I can help with Gaia in general, Gaia DR2, Gaia astrometry, Gaia alerts in particular. What I would like to learn is LSST, microlensing, high angular imaging from the ground and space, the mu-lens and all the other new codes. I've used some of PyLima, but not the rest. And then I'd like to learn about VVV data and also other public large data sets in order to do microlensing searches with machine learning and other approaches. Thank you.
Dominic from the University of St Andrews in sunny Scotland. Given that I'm not such an old man, I only have worked on gravitational microlensing for about 25 years. During that time, I probably gained lots of expertise on getting things wrong. And I'm most curious to hear some thoughts, views, and ideas from younger people.
Postdoc here at CCA. I'm not from astrophysics. I have a PhD in machine learning, so I'm really new in the field, and especially microlensing. So I like to learn a lot about microlensing, about the problems, and get a better idea of everything that's going on for you guys, and find fun and challenging machine learning problems, and maybe see if some of the models I've used and I've developed here could be useful for microlensing, and anomaly detection is kind of also my jam. And I can help others with representation learning and neural nets and some PyTorch coding, I guess.
Use your seat mic, please.
That's involved cadence optimization, simulations, developing metrics, that sort of stuff. I'm keen to be just improve my general skills with some of the publicly available codes. I'm also interested in learning about detection pipelines, particularly with a view to the LSST alert stream forthcoming. So if anyone's got any questions about the LSST survey, simulation framework, etc., I can help with that. I've also used random forest classifiers for the MOA database.
Hi, I'm Samson Johnson. I'm a graduate student at Ohio State, and I'm really, I've been working on simulating WFIRST survey designs. I'm really interested in what we can learn about exoplanets from that. I'm sort of really, I think I'm pretty flexible in with what I want to work on. For some reason, automated event detection is sort of drawing me in, I think, the most, but also how to efficiently pulling out system parameters from microlens events, I think, is also very interesting. And if you don't know how to use Python, I guess I can help you there. Or if you just want like general information on WFIRST, I think I can answer at least some questions.
My name is Yana Kondo, and I'm a master student at Osaka University. And I belong with MOA team, and I'd like to learn about many things. And I like to learn mainly how to weight degenerate solutions in Bayesian analysis. But I want to learn many things, and I can help others with those things. So I'd like to ask you many things. Thank you.
Hi everyone, I'm Fatma Abdurrahman. I'm a PhD student at Berkeley. The two very different things I want to work on are how to constrain microlensing events outside of the light curve modeling, so the kinds of things I was talking about yesterday and beyond, and also opposing that, modeling higher order effects, particularly non-static binaries, something I've been trying to work on unsuccessfully. Because I also do research in AO, I can be helpful with anything AO related, observing PSF construction, whatever. I also do a lot of crowded field astrometry and understanding detection limits in image data.
Konnichiwa from University of Tokyo. I'm a graduate student and working on such a primordial black holes using Subaru data. And I'm very new in this field, and so I'd like to learn more about microlensing modeling in general or statistical approach. Thank you.
Hello, I'm Markus Sundetmark. I'm currently working as a postdoc at the University of Heidelberg at the Astronomisches Recheninstitut. I'm part of the RoboNet team and also involved in the MindStep team, especially with a focus on data reduction. And since our group is also an API team of the LSST, I'm also assigned together with Yannis Tsapras on that one. I can clearly help out with Pylema and how to get the most out of it. I've some expertise as far as difference imaging is concerned, but that might not be particularly useful over here. And I really look forward to learn more on extending my statistical toolbox, optimization techniques, and getting likelihood and similar functions in a way integrated that we can understand what we are observing the very best way.
Hi, I'm Yannis Tsapras. So I'm senior scientist at the Astronomisches Recheninstitut at Heidelberg University. I'm the PI of the ROMRIA project. I used to work at LCO for a long time, so if you have anything, and before that for the Liverpool telescope, so I've been working on microlensing for about 20 years, so I belong to the same generation as Valerio and Łukasz, and I guess Martin and Scott. So I have a lot of experience with microlensing and a lot of experience with robotic astronomy. So if you have any questions about robotic astronomy or microlensing, or if you have problem understanding microlensing light curve morphologies, I'd be happy to talk about that. I've worked on many different things, including transits, radial velocity, variable stars, basically things that go bang in the night. And I'm also a member of the LSST TVS, the microlensing subgroup. What I don't really understand very well is machine learning methods. I mean, I have a general understanding of it, but there seems to be too many options, and I really don't understand which one would be better for the kind of problems that we're dealing with microlensing, because there's a lot of discontinuities in microlensing that you don't see in transits or radial velocities. So the microlensing signals are a lot more difficult, and I'm still trying to get my head around how to use machine learning for that. So that basically covers the second part as well. So dealing with microlensing degeneracies and dealing with systematics in the data. I've done some work on estimating planet detection efficiencies using OGLE data. And I have a lot of experience doing outreach. So if you want to talk to me about outreach as well, yeah, that would be great. And I can help with Python. Thanks.
Hello, I'm Naoki Hoshimoto. I'm a postdoc at University of Tokyo, and I'm a member of MOA team. I'm working on characterizing planetary events using high angular resolution images. So, and I'd like to learn how to weight degenerate solutions in Bayesian analysis. And I'm interested in host mass dependency of planet frequency. And I can help you with calculation of contamination probabilities in excess of blending flux, maybe which is very niche. Thank you.
Hello everyone, I'm Chris Rybicki. I'm PhD student in Warsaw Astronomical Observatory, and I have some experience in microlensing. I'm a fan of astrometric part of it. I work with Gaia, and well, I'm part of Science Alerts team, so I also work on following up the microlensing events. Also in Ogle, I work on gathering the data for the project. And as for helping you, if you have any questions about Gaia or astrometric microlensing, you can just hit me and I will answer or not. I will answer if I know one. And with so many experts in the field, it would be great to learn about well, the most optimal and proper way of using MCMC in context of fitting models to microlensing events, using all these wonderful codes you guys wrote, and yeah, especially I have an event with space parallax, so I'd like to solve that today or tomorrow. Thanks.
Hello, my name is Haruno Suematsu. I'm a master student at Osaka University. I'm working on classifying whether the more DIA image is a star or not by using convolutional neural network. I would like to learn about how to improve accuracy of classifying, and I would like to know about highly marked light curve classifier and parallax simulation between prime and double first. I can help. I'm not sure, but I can help other with more DIA image and convolutional neural network. Thank you.
Hi everyone, I'm Yashar Hezave, and I'm a postdoc here upstairs. And I have no experience in microlensing, but I have a lot of experience in strong lensing, galaxy strong lensing. And actually, my focus in my research is detecting tiny overdensities, like from dark matter subhalos on the extended images of background sources. So it could be thought, about the planet going in front, but the difference is that there's like no time variation in these images. So you have that static, image. And so a lot of that is like trying to detect these things by modeling, these arcs. And we do a lot of that with interferometric data. And so basically that's been what I've been doing for over 10 years now. What I'm very excited about learning here is a little bit probably about variational inference, Hamiltonian MC, and in the past few years we've been doing a lot of machine learning. So we've written like a series of papers like using neural networks in different ways to infer or to get the parameters of lenses in kind of like much faster ways. So if anybody's kind of like interested in working on that, I can contribute to that.
Hi, I'm Michael Albrow from the University of Canterbury. I've, like some others, been in the microlensing game for about 20 years. I work on photometry and microlensing modeling. It looks like part of my things I'd like to work on has been cut off, but I'm interested in all the things that other people have mentioned, but in addition there's some other things I've mentioned there, and the thing that's been cut off is the contour integration method amenable to being recast as an algorithm for GPUs? It's one of my big interests. So if anybody's interested in GPU coding in CUDA, for instance, I can help them with that.
Hi, I'm Kailash Sahu. I'm a staff astronomer at Space Telescope Science Institute. I have been working on microlensing for a long time. Actually, I'm also a co-founder of the Planet collaboration, which looked for planets using the microlensing for the first time. I've worked on many different microlensing projects using HST data. Right now, one thing I'm trying to learn is the astrometric effects on binary lensings. That's not part of this now, but in future probably that should be one of the topics which should be covered, particularly after WFIRST. There would be lots of astrometric effects would be detected. So, and I would like to learn a bit more about Valerio Boza's binary lensing code. If anybody has questions about HST data analysis instruments, I can help. and I have been interested in astrometric microlensing in general.
Hi, I am Sebastiano Guerchinovati. I work at IPAC. Currently, I'm involved mainly with WFest microseat for the image simulation for the microlensing survey. I'm a member of the Spitzer team, specifically for the photometry, so I can help with that. What I'd like to learn out of that is especially the optimal way to explore the parameter space for a multi-lens model, and specifically with the public code that we learn about today.
That appears to be the end. Did we miss anyone? No?
Plug in information into this system. My name is Han. I have been around in this field for 25 years. I'm the third oldest person in this room after Kailash Chahu and David Bennett. I did, start with using microlensing to search for galactic dark matter, and I moved to binary. I moved to what? So I started microlensing modeling for 15 years. I realized that it's time to leave microlensing modeling because so many people are doing it. As Valerio Boccia said, just one button gives you the answer. So what's the use for me? So it's time to leave. So I don't know what can I help. I know nothing about. I'm not familiar with the coding. The only coding I know is a Fortran. What is a Pisces? I do not know about that. So, so that's it. Okay, thank you.
All right, anyone else? Go.
I'm a PhD student at Osaka University. I'm a member of MOAT, and I'm working on the light curve modeling, and I'd like to run and working on how to weight the degenerate solutions, and interested in the triple lens modeling and fast modeling of binary lens events. So I think I can help others with light curve modeling and about more data and general things about microlensing.
All right, so a few last things before we break. So don't forget to add your GitHub username to your slide, and we'll keep an eye on that and make sure that everyone gets added to the organization. And that is somewhere in here. If you go, you'll be part of the everyone team. And this gives us a discussion board where you can post proposals for hacks to work on or breakout sessions. For example, I think we're going to need a breakout on machine learning and neural networks, and there were a few other common themes that came up through here. So keep an eye on this, and we'll make sure that chat with me or Rodrigo if you are having trouble getting access to this discussion board.
And if you don't have a GitHub username, you should create an account. It's super easy and useful.
It is now Microsoft's GitHub, so I don't know how you feel about that.
Well.
And then, so I think we wanted to say something about the collaboration policy. Jennifer, do you want to take over for that?
The hack session website is linked from the main conference website. It's just hack.microlensing.science. And just on the front page, there's some stuff, information about things. In particular, I wanted to remind people about guidelines for collaboration at the Hack Week, which is that, I'll just read it. To ensure transparency and openness, we have adopted the collaboration policy developed for the Gaia sprints. And so this policy recommends that participants agree to the following. All participants will be expected to openly share their ideas, expertise, code, and interim results. Project development will proceed out in the open among participants and in the world. Participants will be encouraged to change gears, start new collaborations, and combine projects. Any participant who contributes significantly to a project can expect co-authorship on resulting scientific papers, and any participant who gets scientific contributions to a project is expected to include those contributors as co-authors. And these rules make it inadvisable to bring proprietary data sets or proprietary code unless the participant bringing such assets has the rights to open them or add collaborators. So just something to keep in mind as you're thinking about your projects and what would be appropriate and what wouldn't be appropriate in this context. And in addition, I just want to remind people that we have a code of conduct, which is summarized in the heading, Be a Nice Person. And if you want the details that's in there, there are also contacts should you encounter problems that may be in violation of those policies. And just below that are guidelines about how that will be handled. So just want to make sure everyone knows about that stuff. And go forth and hack.
I think we have this floor for another hour, I think, before we're supposed to be out today. So feel free to do some mingling, chatting, that kind of stuff, and then we'll be back here tomorrow morning. Great. Thank you.